All right, in this example, we are solving a polynomial equation. This particular polynomial equation is a cubic binomial. We have two terms. We have x to the third power minus is subtraction, or sometimes we use the word difference, find the difference, minus 27. All right, 27 actually has something in common with x cubed. What does 27 have in common with x cubed? Does anybody know? What do x cubed and 27 have in common? That's a big hint. X cubed and 27 are both perfect what? Not squares, but
Cubes.
yeah, they're both perfect cubes. So what we have here is actually something from the very beginning of the school year where we learned the 5 factoring methods. And we learned as our third method the sum and slash or really, the sum and or difference of 2 cubes. When it came to difference, we only did the difference of 2 squares. But sum and difference we do for cubes. So the first thing I'm doing here, if you remember what I called it, is we're putting on our cubing glasses. That lets us see, with our x-ray vision, lets us see what is actually being cubed to make these alleged perfect cubes. X is being cubed to make x cubed, pretty straightforward, and 3 is being cubed to make 27. Then to do our factoring, we made one small parenthesis, and then we made one big parenthesis equals 0. We're just going to keep that equal 0. Now, in the beginning of the year, when we did these problems, all we did was factor. They were not equations, they were expressions. If they're expressions, that means we don't have equals 0 at the end. So it's like, oh, factor x cubed minus 27. So then we would start with x cubed minus 3 cubed. And then we would do this part over here. And then we were done. Now we turned it into an equation. We have equal signs. And it happens to equal 0. That's good. We like the equations to be equal to our happy little 0. And we're going to solve, and we always try to solve by factoring to get started. So with that being said, we got it all set up in our first setup. Now, there was actually words that we used when we first learned how to factor this, and one started with an L and one started with a Q that helped us describe what went in these parentheses. So does anybody remember what we said about this factor? Factors are things that multiply, okay, to give us a certain answer. What did we say about the first factor and the second factor regarding the letters L and Q? You could just shout out if you know.
One of the parentheses were a linear expression,
Yeah.
and then the other was a quadratic
Good.
expression.
One is linear and one is quadratic. Okay. And then I had my silly way of helping us remember. So when I post this video, I will link either in the description or at the end or maybe both. I'm going to link the video that brings you to the lesson on how to factor cubes, sum and difference of cubes. So if you forgot, you're going to have to remember that. Okay. So to get the linear, this is where I told you we take the little 3's, we put them in our pocket, and we save them for later. And so what do I write down in this parenthesis right here? Who remembers what goes in this parenthesis right over here? It's going to be linear. So it's a plain x, x to the first power, x minus 3. Now, next thing that we're going to do is the 3's are going to be our fairy dust. We're going to sprinkle some 3's here, and we put 3 dots on the paper. That's our fairy dust. What's x times x? That's x squared. What's x times 3? That's 3x. And then what's 3 times 3? That's 9. If you notice, I did not worry about the negative sign in the middle. We don't worry about that yet. So x times x, all right, that gave us x squared. After that, hopefully some of these highlighters will work. I don't have my regular pens handy. Then x times 3 is what gave us this 3x. And 3 times 3 is what gave us the 9. Okay, then we spelled out a word to help us fill in some other pieces here. Does anybody remember what word, four-letter word, we wrote out?
So.
Yeah, S-O-A-P. And what did those stand for? S stands for?
Same.
Good, same. So it means it's the same sign as the original problem. O stands for?
Opposite.
Opposite, nice. Opposite, and it's the opposite of whatever that is, so plus. And then AP is?
Always positive.
Yeah, everyone says positive. I feel like I always say always plus because it's less to say, fewer syllables, but you could put positive, obviously, that means the same thing. There we go. Now we have to continue to solve. So this right here, we went over this in the beginning of the year, but I know people are going to forget. This is going to be not factorable, I promise, because if it was factorable, it would have been part of the rule for coming up with the factored form, right? Like, why would we create a whole technique and not finish it? So that is not factorable. That is already a linear. So when we are trying to solve something like this, when it's linear, we just go ahead and set that equal to 0. So let's do the first one. So we're just going to kind of continue over there, okay? So x minus 3 equals 0. I'm going to add 3 to both sides, and I get x equals 3. What kind of answer is that? Is x equals 3? Is that a real answer? Is that an imaginary answer? How many answers did I just find? What is that? What is that? It's one real solution. Good. One real solution. So that right there is one real solution, just x equals 3. There's no I attached to that. That's not imaginary. So one real solution. And that was part of our hint. We should have gotten one real solution. So what does that mean moving forward? Well, 2 imaginary solutions we should get from solving that part right over there, okay? We should get 2 imaginary solutions. How should I solve this quadratic if it's not factorable? How do I solve a quadratic when it's not factorable? Come on, guys. We've been doing this for a few days now. Just shout it out if you know.
Quadratic formula.
Yeah, we use the quadratic formula. X equals, nice and slow, ready? I'm a little bit squeezed, but we'll get there. Negative b. What do I put for negative b? Help me out, we're almost done. Negative 3? Good. Plus minus the square root. Plus minus the square root. B squared, that's 3 squared, minus 4. A is 1. C is 9. Sorry, it's so squashed. 1 and 9 right there, okay? Negative 3 plus minus the square root of 3 squared minus 4 times 1 times 9 all over 2a, which is 2 times 1. Then I'm just going to make it bigger over here. X equals negative 3 plus minus the square root of. All right, 3 squared is 9 minus 4 times 1 times 9. Well, that's going to be 36. And just to save space, because I'm at the end of my page over here, what's 9 minus 36? I'm just going to squeeze it underneath here. 9 minus 36. Negative 27. And negative 27, that's going to be 3 times 3 times 3. But Hashara told us what that negative means. What does that negative mean?
I.
It means I for imaginary. You're absolutely correct. So I square root 27. But 27, I just told you, is 3 times 3 times 3. I mean, it's 3 cubed, right? Over 2. 2 times 1. A pair makes a square, so that 3 times 3 can come on out of the square root. And our final answer will be -3 plus minus, that 3 comes out because it's a pair of 3's, it comes out, so it's 3i. That 3 right there remains on the inside all over 2. Nothing reduces. Now, there's a plus minus in that middle. That means we really have 2 answers right here. What kind of answers are they? Solutions? They're imaginary because they have the I. Okay? So we have 2 imaginary solutions right over there. So at the end of the day, what did we get? I'm just going to grab a color pen over here, maybe to color coordinate this. This over here, -3 plus minus the square root. This doesn't really work. So much for that. Plus minus the square root, b squared minus 4ac. Oh, I have a blue marker I could use. There we go. This right here are our 2 imaginary solutions, which we reference over here in the hint. So how many answers did we get all together? We got 3 answers all together. Now, that was something we also talked about a long time ago. We said the power of the polynomial tells us how many solutions in total you will have. So we have 2 imaginaries and we have 1 real. So we had 3 solutions for this cubic equation. So that's the end of this example, solving a polynomial equation, specifically the difference of 2 cubes. Hopefully we all remember how to factor the difference of cubes. If not, you should go over that. And I'm going to assign you homework right now to do. So it's going to be 1 more of these types of examples. So you're going to do exactly one like that. So your homework is assigned right here on your own. And you'll post that to be graded. Solve 125 x cubed plus 8 equals 0. Same rules apply. You're going to have 1 real answer, 1 real solution, and then you're going to have 2 imaginary solutions as well. So that is the example you're doing. It models exactly like the last one. So hopefully you understood that. If you understood the last one and you feel like fairly confident on this one, thumbs up. If you don't feel confident to do it, put a thumbs down, and we will address it next class.